Imagine being able to confidently showcase a real world SQL project in your portfolio as a beginner data analyst, scientist, or even a data engineer. In this complete SQL coffee shop case study, I'll walk you through 21 business driven SQL queries from simple to highly complex that cover almost every SQL concept you will ever need. You will learn how to create a database from scratch, run a ready-made SQL script to set up all your tables, import raw CSV data, and solve real-world business scenarios step by step. And the best part, you will get the full data set and source code in the description, so you can practice solve your own questions and proudly add this project to your portfolio. I have already created a coffee shop DB. You can create it by just running this script, create database coffee shop DB. I have already written a SQL script, so you can just run it and all tables will be created. You can see it on the screen. So you can see in our coffee shop DB, this is our coffee shop DB, right? There is no tables yet, so we will run this script and all tables will be created. So let's run it. You can run it by doing that. I will provide the source code in the description. Now let's look at the tables. First let's refresh it. You can see all the tables have been successfully created. Now let's import data into those tables. Right click on the coffee shop, click on import export data, and click on that icon. This will locate you to the directory where all CSV files are present. Click on the CSV file of coffee shop, open, click OK, and the data will be imported successfully in the coffee shop DB. Now do the same for all of these tables, and you will import the data into each table of this database. That's the last table, staff. Data is successfully imported into every table. Now let's look at the tables. We'll explain each table step by step. So the first table is coffee shop. Let's run the select all from coffee shop script. This table helps connect rota, staff, and shift tables. Now ingredients. This stores information about ingredients and its price. Now inventory table. This table stores information about inventory, ingredients, and quantity of ingredients in each inventory. Now menu items. This table stores information about menu items, its category, size, price, etc. Now orders table. This table stores information about orders, its order date, items, customer name, quantity, etc. Now recipe table. This table stores information about recipe, ingredients used in recipe, and their quantity. Next table is rota. It's like a scheduling system. This stores information about shift and assigned staff. Now shift table. This stores information about shift, their day, start time, and end time of each shift. Staff table stores information about staff, their name, last name, position, and their salary per hour. When we start writing the queries, everything will be crystal clear for you. I'll put the source code link in the description so you can download it from there and showcase it in your portfolio. That's the main file we will write queries in. In the screen you can see SQL concepts to cover. These are all the concepts we will implement in our queries. Also there are extra ones, but these are the top and core concepts we will understand and implement in each query. Now all the questions you can see on the screen, contains real world business scenarios. We will write queries for all those questions in this coffee shop case study series. Today we are diving into something really exciting, employee workload and shift management at a coffee shop. This is the first part of our coffee shop case study series where we'll break down real world problems and solve them using SQL. So let's get started. So query number one is calculate total hours worked by each employee per week. First, we need to calculate the total hour worked by each employee in a given week. The goal here is to get a clear view of how much employee contributes weekly, which helps in shift management and workload distributions. To achieve this, we need employee identification from staff table, date information from coffee shop table, and time calculation from shift table. So we are going to use these three tables. So let's understand the staff table. This table contains staff ID, first name and last name, all information about staff. Now the second table is shift table. It has start time and time to calculate worked hours. And this is the coffee shop table. It contains date, shift ID, and staff ID. We will extract the week from the date column. Also, coffee shop table will help us to connect shift and staff tables. So let's begin writing the query. We start with select statement. Select staff information, staff ID, first name and its last name to identify the employees. Staff dot first name and last name. So now we will use a date trunc function. Now this function is mainly used to truncate a date or time steps value to a specify unit of time like a day, month, or year. In the first parameter, we'll pass week because we need weekly data, and so this is the date column, right? So we need to extract week from it, and in the second we'll use the coffee shop date column alias week starter. Why we use week start is because we need weekly data. So whenever you encounter a scenario where you need weekly data, then you have to use week starter. Next, we will calculate the worked hour using sum and end time and start time from shift tables. We'll subtract end time from start time and it will give us total worked hours. Alias total worked hours from staff table. We'll join coffee shop and shift table with staff tables. We will join a coffee shop table with staff table using shift ID, right? Why in a join? It's because we only want to filter out the matching rows. So this is staff table. It contains staff ID. So on this that staff ID, we will connect with coffee shop table. Right. This is a staff ID, and then the shift ID will connect with shift table. This is the shift table, and also coffee shop contains shift ID. So join coffee shop alias CS on staff data staff ID should equal to coffee shop dot staff ID. And now we'll join shift table. So we will join shift table with shift ID. So join shift S on coffee shop that shift ID should be equal to shift data shift ID. It's because we are filtering out the matching rows, right? Group by 1, 2, 3, 4. 1, 2, 3, 4 means staff ID, first name, last name, and week start because we need information about each staff member for each week. And finally, order by s- staff ID, staff data, staff ID. So let's run the query. So we have made a mistake here. So the CS.data it's a character variable, it's not a date table. So we'll typecast it to date table. The two colon is used for typecasting in Postgres SQL. So we'll typecast character varying date column into date type date column. So we can use date time functions. So let's run the query. Now the query output shows staff ID, first name, last name, week start, and total worked hours. As this query group the shift durations per employee per week by using a date trunk. So we ensure all shifts from the same week are treated as one unit, which makes it easy to calculate the total work hours. The query is completed, so let's change the type of date column in coffee shop table from character to data. So we will perform date time functions on that column. So alter table coffee shop alter column data into type data. Type means we want to assign a date type using data typecast to data. So this script will convert the date column in from character to date type. Now, as you can see, it's converted from character to date type. So now the second query, it tells us to identify employees who have worked more than 25 hours in a week. This helps in detecting overtime and managing the workload efficiently. First, we reuse the previous logic to calculate the weekly hours. So this was our first query for identifying weekly hours per week. So we will use this and wrap up in a sub query to filter out those who worked overtime. So this was our query, and now we will select the same columns like staff ID, first name, last name, and week starter. And then we will filter out the result where total worked hour is greater than 25 hours. So first name, last name, week start and total worked hours from from the subquery. So we can name it as subquery or you can give the name you like. So let's say subquery. And now we will filter out those who are working greater than 25 hours. For this, we will use where clause. Where total worked out is greater than interval 25 hours. So what is interval? It is used to represent a period of time like hours, days, weeks, or even years. It allows us to perform date and time calculations easily. You can adjust the interval to different times, like one day, 2 weeks, 30 minutes. So let's run the query, see the output. So this is the output. These are the employees who are working overtime, which is 20 greater than 25 hours. So you can adjust it based on your business requirement. The second query is completed. So let's focus on the third one. It says rank employees based on the total work hours. So we will use the previous query logic. The first query. This time we will use a CTE instead of subquery. So let's start with the employee worked hours as and now here we will paste our first query logic to identify total worked hours. So in the city, it uses weaker to identify total worked hours. But in the question, it's not mentioned. So why did I choose weaker? It's because if I choose a day instead, the same employees might appear multiple times with different ranks. So that's why I used weaker. If needed, you can switch to day by just changing the weaker inside the dead trunk function. Now we'll select employee details from employee worked hour, city, staff ID, first name, last name, and assign a rank to them based on their worked hours. We'll use the rank function. It allows us to assign a rank based on the total hours. With the highest hours rank first. The way we can easily see the most hardworking employees. Total work out and rank over order by total worked hours descending. This ranks employees based on most hours worked. The order by sort from highest to lowest hours, allowing us to see the top performance first. And we name it as rank top working employees from employee worked hours, which is a countable expression. Let's run the query to see the output. Let's correct the mistakes. Forgot about is and a comma after total worked hours. So now let's again run the query. So the query output shows employees their total worked hours and their rank. We can also rank them using a dense rank function instead of rank. And the difference between them is dense rank doesn't skip values. It will show 2 after 1. So as you can see, it show first and second position and doesn't skip the second position where ranked it. Well, in this video, both queries have been completed. Hey everyone, so this is the fourth query of our SQL case study and it says suggest an optimized shift relocation to balance the workload. So the goal is to find the overworked and underworked employees and then suggest shift relocation. So we need to create first a temporary table or a CTE to calculate how many hours each employee has worked. And for that we will use the previous query logic, the first query logic, which extract total hours from for each employee, right? And it's for weekly. So let's begin writing the query. First we will start with the with clause with and name it city employee hours. Employee hour as and now we will copy the first query logic to identify employee hours. This extract hours for a week. So we have to remove the week start and also we used week start in group by to group it by week start. So we'll first remove the week start and also remove it from group by, because we don't need a weekly hours. Now select all and press tab for a better structure. Now we will create another CTE to identify overworked employees from the current employee hours, and we will set the condition where total worked out is greater than 25. So this will be overworked employees. So let's do this. Now you can't use with clauses, so we'll directly start with the overworked as and then we will select the staff ID, first name, last name, and total worked hours from employee hours. And our condition is overworked employees are those who worked greater than 25 hours, right? So it depends on your business rules, so you can change the condition based on your business rules. So we'll first remove the alias because we are getting it from employee hours, and we will remove the staff table alias. So let's remove it from employee hours because we are selecting it from employee hours temporary table. And now we will set the condition where total worked hours is greater than 25. So this is the overworked employees. Now we will select underworked employees who is working less than 25 hours. You can set the condition based on your own business rules. So here we will only change the condition, also the name underworked and we'll change it less than 25 hours. For better readability, we'll select it and press the tab, so the structure would look very good. Now comes the smart part. We will cross join the overworked and underworked employees. That means we take every overworked employee and match them with every underworked one. So we get a list of all possible pairing and we suggest consider shift allocation, which means think about giving some hours from this overworked employee to the underworked ones. For consider shift allocation, we can use extra column. Let's begin working on the main part. We will start with the select statement and we will select all the details from overworked employee. O means O is the alias of overworked employees and we name it overworked ID and overworked the first name, last name, right? First name as overworked first name and we will copy it for the underworked employees and we will use u is the alias of underworked employees and we will call it underworked id. Also u for first name from overworked. Oh, and we will use a cross join now. Cross join because we want list of all possible pairings. So cross join underworked alias u. So now we will add one crucial column which is suggestion and we'll only use a consider shift relocation in that column because if someone is reading it then he understand that I should consider shift relocation between these employees. So let's add the crucial column which is suggestion and this column will only contain this text consider shift reallocation, right? And we'll name it as a suggestion. So the query is completed. Let's run it to see the output. Now there is an error occurred and it says interval which is total worked out is greater than integer. That's because the subtraction of end time and start time return an interval, not a number. So we can directly compare interval with a number like 25. So I should use a smarter way and first we will get the seconds from the end time and start time subtraction and then divide it by 3600 to convert seconds into hours, right? So first we will use extract function to extract the seconds from the subtraction of end time and start time. So let's use the extract function extract. Now we will use epoch. This selects seconds from start time and end time. So now we will divide it on 3600 because in 1 hour the seconds are 3600 and then take sum of it, divide by 3600. Now I believe this will work. So let's run the query to see the output. Now the query runs successfully and now it returns overworked ID and its first name and underworked ID and its first name and also suggestion for consider shift relocation. We used cross join and you can see on the screen that it returns pairs of underworked and overworked employees, right? You can watch the video again if you have any confusion. I have explained everything very clearly. Hey everyone, so this is the second part of our coffee shop case study and the fifth question says that take employees with overlapping shifts same date or overlapping times. So we will identify shifts where more than one employee is scheduled to work at the same time, right? This is useful for workload planning, avoiding crowding or coordinating teamwork. We'll work through the query step by step and explain a new function called a string aggregator, which help us combine employee names into a single line. So let's begin. First, let's understand which tables we are going to use in this query. So this is the staff table, right? It has all the information about staff, right? And the second table is shift. It has all the information about each shift and its time, like start time, end time. And the third table is coffee shop. It has all the records of which staff worked when, right? Like shift id, staff id, date, etc. So let's start writing the query. First we are starting with a common table expression, and we name it overlapping shifts to extract overlapping shifts. It's a temporary table, right? With overlapping shifts as now we are selecting shift id and date from coffee shop table, coffee shop the date, and start time and end time from shift, right? Start time and end time, shift at end time. Now we are using string aggregate function to combine all the employee names assigned to this shift. In the first parameter, string aggregator, and the first parameter we have to pass the expression, and in second the separator, right? So in first parameter we have to pass the names for concatenation. Okay, so start at first name and its last name. We'll use the concatenation operator used in Postgres SQL or some other SQL databases. And this is the space, and now we'll give the last name, right? Now in the second parameter we will use this operator to separate employee names who is working together. And let's name it as employees because it's showing the employees that are working together on the same shift, right? As employees. Lastly, we will count how many employees are working in the same shift using count function. We are using count star because it counts all the rows in the same result set regardless of null values, making it safe and reliable for counting total records like employees on a shift. Let's name it employee count from coffee shop table, and we'll use alias CS. After that we will use inner join to connect the three tables only where matching data exists. These give us a list of employees and their shift at the coffee shop and leaves out any incomplete or mismatched records. So this is the shift table. We will connect it with shift ID. Now join shift as alias on coffee shop. The shift ID should be equal to shift id, and now again we will join a coffee shop table with staff table, staff st on coffee shop dot staff id should be equal to staff dot staff id. Inner join will give us only the rows where matching data exists, right? Well, now we will group the data by each shift time, so we can count how many employees work together in that time slot, right? Also, if you are using aggregate function, you must use a group by clause, otherwise you will get an error. So group by ch.shift id CS is the alias of coffee shop, right? Coffee shop dot date, staff dot start time and staff dot end time. Okay, so let's run the query to see what it returns. Okay, there is a mistake. I forgot about the concatenation operator, right? Between the first name and the last name. So I have to add it. Let's run it again. So in the output you see the shift and its start time and time and employees that are working on that shift. Also its count, right? Now we'll use a condition to filter the data where two or greater than two employees are working on the same shift. I have this condition and it depends on every business, right? You can set it based on your own business rules. For me, if two or greater than two employees are working on the same shift, then it's overlapping shift. You can set the condition, right, based on your own business rules. Having count star greater than one. Where we are using having instead of where, because where filter rows before grouping and having filters groups after grouping, right? Also you cannot use aggregate functions in where clause, so you have to use it in having clause. So this will filter only the rows where two or more than two employees are working on the same shift. So let's run the query to see the output. Now it filters all the shifts where employees are two or greater than two. You can so the query is complete, right? But why did I use CTE? Because you can set a condition on employee count, right, outside the city, and also do many other things like rank or others. So that's why finally we'll select the full result from our temporary table and order it by date and shift ID. So it's easy to read. Employees count from overlapping shifts, order by date and shift ID. Well, let's run the query. Okay, so the error is we forgot the S employees count. Let's run the query again, and as you can see on the screen, the output shows employees greater than one. We don't have shifts with employees greater than three, right? So that's why it's only showing two. Now I change the condition to greater than two, and you can see it shows nothing, right? So it means there is no shifts with employees greater than two. Now this is the sixth question of our coffee shop case study, and it says identify shifts with insufficient staff, right? Now the condition I used here is based on my own business logic. I have defined a shift as insufficiently staffed if one or fewer employees are assigned to it. That means if there is either only one person or no one at all on that shift, I want to flag it, right? This is just one example. You can definitely customize this condition based on your own business rules. For example, in a bigger coffee shop, you might consider anything below three staff members as insufficient. So again, this part is flexible. The key is you define what insufficient means for you and for your business logic. Now for the logic itself, we'll be using the same structure we built earlier in the overlapping shifts query, right? It's the previous query, and the only thing that really changes here is the condition inside the having clause, where we write having count star is less than equal to 1 to isolate those understaffed shifts. I hope you understand that. Okay, so now we'll copy the part of the previous query where overlapping shifts is extracted from coffee shop shift and staff tables. and here we will only change the condition, right? Let me run this query to see what it returns, and the query returns, you can see the employees greater than one, right? We will only filter shifts where employees are less than or equal to one. So let's modify the condition. Having count of employees is less than equal to one, then there would be shifts with insufficient staff, right? Let's run the query now. Now on the screen, you can see on the output, it only returns the shifts with employees count is less than or equal to 1. So we don't have any shifts with employees is less than 1, right? That's why it doesn't return it. So in this section, we are diving into sales and revenue analysis. Specifically, we will identify the busiest hours of the day based on total sales. This will help you understand when your shop makes the most money. Okay, so first look at our two output columns. The first one is the busiest hour, and the second is total sales. Our goal is to see which hour has the most total sales. Well, we are going to use two tables, menu items and orders, to identify busiest hours based on total sales. Let's understand the menu item table. This table contains item price and item ID. So we are going to use item price for total sales and item ID to join orders table with menu items table. Okay, so now let's understand the orders table. This table contains a quantity. We'll use quantity with item price to identify total sales and created data. From this created data column, we will extract hours to identify busiest hours. Also, this table contains order ID, so we can join both tables using this order ID. Okay, so let's start writing the query. First, we will select busiest hours, and for that we will extract hours from created at column using extract function. So extract this function extract a specific time period from date column. So we'll extract hours and then from now created date column. This is a date column, so also it's in a text form, right? So we'll convert it to timestamp using typecasting, right? Orders dot created data, and now typecast it to timestamp. You can also use cast function. Okay, we are labeling it as a busiest hours. Next, we'll calculate how much money each order bought in by multiplying a quantity by item price. Then we use sum function to add up all these orders amount. It will give us total sales for each hour. Okay, so sum orders dot quantity multiply by menu items dot item price. This will, and we will label it as total sales. This will give us total sales, right? From orders table alias O. Okay, so now we'll join our orders table with menu items, so we can get the item price for every order. We'll use item ID to connect both tables. Okay, join menu item on orders that item ID should be equal to menu items that item ID. This clause makes sure that we match each order to the correct menu item. After that, we will group the data by the busiest hours column. This means we will collect all orders that happen in the same hour and calculate one total sales number for each hour. Group by busiest hours. Also, if you are using aggregate function, then you have to use a group by clause. Finally, we will sort the results by total sales in descending order. The hour with the highest sales appears at the top, which will be our busiest hour. Order by total sales in descending. Let's run the query to see the output. Okay, so there is a syntax error. We forget about from keyword from orders. Again, now this is the output. Okay, so 12 p.m. is the most busiest hour. In the second, 7 a.m. And the third one is 13. 13 means 1 p.m. And so on. These videos take too much efforts. So if you have not subscribed the channel, then please subscribe it and hit the like button. Hey everyone, welcome back to Data Sync. So this is the at query of our coffee shop case study, and it says to build monthly KPIs and then turn it into a view. By the end, you will see a one-line summary for each month and know how to save it for the future reporting. You can see the output at the bottom. So then we will create a view from that. It's a month revenue per month, total orders per month, and average orders value. We showed a month as a number, and also we have only 1 month data. That's why it's showing only two, right? So our query will return this output, and then we will convert it into a view. If you see in the coffee shop database, there is no view yet, right? Before starting the query, let's understand the tables we are going to use in this query. Menu items, we will use item price and item ID from this table. Okay, the other one is orders table. We will use quantity and create it at timestamp from this table. Also, we will connect it with menu items using item ID. Well, let's begin writing the query. We will start with select statement. Then we will extract month from created at timestamp using extract function. In MySQL, you can use month function instead of extract. So extract month from orders data created at column. Orders dot created at column. This column has a text data type, but you cannot perform date time functions or operations without typecasting it to timestamp or data. So we'll typecast it to timestamp and we'll label it as month. We need a month to group sales by month because we need monthly KPIs. Okay, now revenue per month. For that we'll use sum of orders dot quantity multiply by menu items dot item price. This is the item price, right? Okay, so sum of orders dot quantity multiply by menu items dot item price. This will show how much money we made in each month because we'll group it by month and we'll label it as revenue per month. Okay, now item sold per month. What it does, it adds up all the item quantities sold in the month. Why? Because to see the total volume of items sold each month. For that we'll use sum of order dot quantity and we'll label it orders per month. You can also use items sold per month. And when we group it by month, this will show orders per month. Now finally average orders value. For that we will divide revenue per month by count of distinct orders ID. Okay, so revenue per month we'll use this revenue per month and divide it by count of distinct orders dot order ID. Why we'll use distinct word? It's because we don't want similar orders to be counted multiple times. So distinct orders data order ID and we'll name it as average order value. Let's drop it to the third line for better readability. From orders table alias or O is a short nickname, right? Well, now we'll join orders table with the menu items using item ID. Okay, what it does, it brings in the item price table for each order by matching on item ID. Why? Because without the price we cannot calculate revenue. Okay, now the important part, group by month. What it does, it tells SQL to calculate each of our selected metrics separately for each month. Why? Because we want one result row per month. Okay, so group by month. Also, if you are using aggregate functions, you have to use group by clause. Okay, so finally we'll order by month in ascending order. What it does, it shows the final results from January through December. Okay, so let's run the query to see the output. You can see the output. It shows month revenue per month, orders per month, and average orders value. Now the average orders value contains too many decimals, so we can use a round function to round it only 2 decimals. Okay, round in first parameter we will a column and in second parameter it wants the number of decimals, right? So this is the syntax. Now let's again run the query. As you can see, the average order value has now 2 decimals. Instead of using 2 columns, you can also use a cast function to cast the data type to timestamp. Now cast order created as timestamp, right? This is the syntax. Query runs successfully. Now the final part to create a view from it. Now the final part to create view from it. So for that we will use a keyword creator and then view and then its name like monthly KPIs, right? And then is. So there is no view present in the database yet. And let's run the query. The view is created. Now let's refresh the view and see it. Now the monthly KPI view has been successfully created. You can see the columns of monthly KPIs. View is like a saved report you can call up whenever you need it. Okay, now the query is completed. If you have not subscribed the channel, please subscribe it and press the like button. See you in the next video. Hey everyone, welcome back to testing. So we are working on revenue and sales analysis. In this query, we want to find the single most profitable product category in our coffee shop, like hot drinks, cold drinks, or pastries. We look at how many items were sold for both in shop and takeaway, like in versus out, the total number sold, and the total revenue generated. Finally, we'll pick the category with the highest sales volume. Well, the below is the output. We'll find a profitable category, quantity sold out, in, and total quantity sold. Finally, we'll limit the result to 1 and the query will extract the most profitable category. Now for this query we'll use 2 tables, menu items and orders. So let's look at the menu items table. So from this table we will use item category to extract category, also item price for revenue, and item ID to join both tables. Well, now orders table. From this table we will use quantity, also in and out to extract quantity sold out and in, and orders ID. Well, let's begin writing the query. We will start with select statement to select the columns. So select and first we will extract category from menu items. Menu items dot items category as profitable category. Then we will extract quantity sold out. Now for that we will use sum function, and in sum function we will use a case statement. Now case when orders data Now in and out column, right, we will use for that in and out equal to out, then we will count it, then quantity, orders dot quantity, else we will count it as 0, else 0, and we will label it as quantity sold out. Quantity sold out means how many items were sold for pickup or delivery. Let's move it to the second line for better readability. Now quantity sold in. For that we will use the same logic, just we will change out to in. Here in means inside shop. Well, we will name it as quantity sold in. Now here what we have done is if orders that in or out equal to in, then count quantity, else don't count or 0. Now total quantity sold, we simply add up every quantity sold both in and out. So sum orders dot quantity, this gives us the overall number of items sold in each category from menu items, and we will call it MI. It's a short name, right? And finally we will join both tables using item ID, because we link each menu item to its sales record by matching item ID in both tables. We call the orders table O, and now we will join both tables using item ID. mi.item ID equal to orders.item ID. Finally, group by menu items that item category. Why? Because we will tell SQL to group all rows by each distinct category name. So every aggregation is calculated per category, not across the whole table. Well, so group by menu items that item category. Finally, we will sort the results in descending order, so the category with the highest total items sold comes first. This helps us easily see which category is the best seller. Okay, so order by total quantity sold. First, let's leave it in ascending order, then later we will sort it in descending. Let's run the query. Okay, there is a mistake. I forget about then keyword, so I have to use it then order.quantity. Okay, again, now here is a syntax error, so it's orders table, not order. Now again run the query. Well, this is the output, but now two things are missing. One is to sort it in descending order, so the most profitable categories will shown first. So we have to use descending keyword to sort it in descending order. So let's use it and again run it. Now you can see it shows the most profitable categories first, second and third in descending order. Now we will limit the result by 1 because we want the most profitable category. So hot drinks is the most profitable category with 277 total quantity sold. We forget about the most crucial column, which was total revenue per category. So for that we will use the previous query logic where we identified total revenue per month. So here we grouped it by month. Now there in our query we will group it by category, so it will show category wise revenue, not monthly. So again let's run the query, and now it shows revenue per category, which is 1081.10. Thanks for watching. Please subscribe the channel and press the like button. See you in the next video. Hey everyone, welcome back to Data Sync. So in this phase of our coffee shop case study, we are working on customer order patterns and retention, and we want to identify customers who place at least 14 orders in a given week, right? This helps us spot our most loyal frequent buyers, and it is critical for retention strategies like loyalty rewards or targeted promotions. So The below is the output of this query. Let's understand it. When you run this query, you will see one row per customer week with these columns: customer name, like name of the customer, month, the calendar month of the order, 1 to 12, right? And week of the year, week number in the year, it starts from 1 to 52. And week of the month, like week number within that month. Also total orders, like how many orders that customer placed in that week. So in our database we have only the second month data, also the second week in that month. So that's why you are seeing only the second month. Well, we are using orders table, so let's understand it. From this table, we will use date column created date to extract month and week alongside quantity to count total orders and customer name to know which customer placed the orders. So let's start writing the query. We will start with select statement to select the columns, and we will select customer name, and now we'll extract month from created date timestamp. We'll use the extract function to extract it. Extract month from created date. Created date is in a text form, right? So we have to typecast it to timestamp so we can perform the time date functions. And we'll label it as month. This helps us know which month the week falls in. And now we will extract week. We'll use the same method, just change month to week. Week from a created date, and we'll typecast it to timestamp. If this column was in a timestamp form, then we don't have to typecast it, and we'll label it as a week of the year. This gives us the week number in the year, so we know the exact calendar week. Now week of month. Now for that there is no function in PostgreSQL, and to achieve that we will use a formula to extract day from the created date column, and then subtract 1 and divide it by 7, and again then add +1. Also we will use floor function, because if what floor function do, if for example the value is in decimals form, like 4.75, then it will be considered as 4. It would be the 4th week. So for that we will use floor function. So let's start writing the logic. First we will use extract day from the date column created date, and we'll typecast it to timestamp, and we will subtract 1 and close this expression in brackets, and we will divide it on 7. And now we will close this whole expression in floor function, and then again we'll use the +1. This is the formula, right? And we'll label it as a week of month. And finally total orders. For that we will use a count star. Why we don't use count quantity? It's because count star count the null values as well, so we don't want to miss it. This counts how many orders fall into each customer week group. We will name it as total orders. From orders is because all our data comes from orders table. Now we'll group it by customer name and all these time buckets, so we can count orders per week, right? So customer name, month, week of the year, and week of the month. Also remember, you cannot use aggregate function in group by clause, and if you are using aggregate function, then you have to use group by clause. Well, now we want customers who order at least 14 times per week. Now for that we'll use a filter to only group where total orders is greater than equal to 14. Now count star, we cannot use it in where clause, so for that we will use a heavy clause. Whenever you have a situation where you have to use filter on an aggregate function, then you have to use it in having clause. Well, so having count star is greater than equal to 14. This will keep only the groups where that customer placed 14 or more orders in that week. And finally, orders by total orders in ascending. This will sort from lowest to highest, so you will see 14 orders weeks first, then 15, then 16, and so on. For running the query, let's first select these columns and press tab 2 times to give it a better structure. Let's run the query. Now the output shows the customer name, month of the year, week of the year, and week of the month, and its total orders in ascending order. If you have not subscribed the channel, please subscribe it and press the like button. See you in the next video. So this is the 11th query of our coffee shop case study, and we are currently working on customer order patterns and retention. And the query is saying identify customers who have not placed an order in the last 30 days. We will solve this query with two methods. One is not in subquery and left join. In the first method, we will build a list of customers and then exclude them using not in. We are using order table, so let's look at it. We will use created a date column from this and customer name. In the first method, we will find the customers who have ordered in the last 30 days and then exclude them using not in, because we want customers who have not ordered in the last 30 days. So let's start writing the query. We will first start with the select statement. First we will select a distinct customer name. Where distinct customer name? It's because we don't want one customer appear more than one time from orders table. Now in where clause, we will filter out those customers who have ordered in the last 30 days. Now for the last 30 days, we will use current data subtract interval 30 days. This gives us the data 30 days ago. So where created a timestamp, its type is text, so we have to typecast it to timestamp, because without that we cannot perform time date functions. So two colons and then data type timestamp, and then we will say that created a timestamp is greater than the last 30 days, and for that we will use current data, it means today, and subtract it from the last 30 days. So current date will give us the current data and subtract, and we will use interval 30 days. This tells SQL to go back exactly 30 days from today. An interval gives you a specific interval like 30 days, 2 days, 1 year, based on what you mentioned inside the double quotes. So let's run this part, and I'm sure it will return nothing, because our database contains data from February 2024 second month onward, and today is June 25, so it won't return anything. Now we'll select those customers who have not ordered in the last 30 days, and for that we will the same distinct names from orders table, and we will filter out those customers who have not ordered in the last 30 days. The below scripts returns the customers who have ordered in the last 30 days, and in this we will filter out where, and in this where clause we will say customer name, where customer name not in, and we will wrap up in this script. The subquery returns customers who have ordered in the last 30 days, and in the above scripts we filtered out those customers who have not ordered in the last 30 days using not in. Let's run the query, and this query will return all the names, because these customers have not ordered in the last 30 days. Wait, if you were writing this query on March 15, 2024, what would it return? So let's do this. First let's give it a better structure to the subquery. Press tab. Now it looks good. Let's say we are writing this query on March 15, 2024, and we will see what it returns. Let's look at the orders table. so you would understand the data. We now, as you can see, the data is from the second month and also from the second week of 2024. Now in order to do that, we will copy the same query, just we will change the current data into date 2024, third month and 15 day, right? And it will return those customers who have not ordered in the last 30 days. That means we will only get those customer names who were ordered before 15th February 2024, right? Okay, so here we will set date and then double quotes and year 2024, third month and 15 day, right? So we will copy this data and paste it there. Okay, so the query is completed. Let's run the query to see the output. Now the output shows those names who have not ordered in the last 30 days if you were writing the query on 2024 third month and 15 day, right? So this is the query output, and the name you have seen are those who have ordered on day 12 or 13 or 14 but before 15, right? Before 15 on the second month and never ordered again. For this query there is also another solution using left join. We'll see it. Before, if you have not subscribed the channel, please subscribe it and click the like button. That gives us motivation to make more videos like this. Well, in this left join method we will copy the same query and paste it here. And now in the comments let's say solution with the left join. Now here we will use the sub query as second table order 2, and then we will join it with order 1 using customer name, and then we will filter out those customers from order 1 who are not present in order 2 table. Order 2 table have those customers who have ordered in the last 30 days, right? And we want those customers who have not ordered in the last 30 days. Now we will use the sub query as left join, and we will label the above order table as order 1, right? And this table in the sub query we will label it as order 2, and now we will join both tables using the common column which is customer name. On order 1 dot customer name should be equal to order 2 dot customer name. In the where clause, now we will filter out those customers whose names are not present in the second table, which is order 2. This will give us the customers who have not ordered in the last 30 days, right? Now here we will write where order 2 dot customer name is null. So the query will return those names from order 1 table whom are not present in order 2 table, because if it's null in order 2, it means that are the customers who have not ordered in the last 30 days. I hope you understand. I have explained it in a very clear and simple way. Now let's run the query to see the output. Okay, well the output is the same like the previous query, right? If you see the previous query output, both would be the same. Thanks for watching. If you have not subscribed the channel, please subscribe it and hit the like button. See you in the next video. Hey everyone, welcome back to Data Sync. So in this segment of our coffee shop case study, which is customer order patterns and retention, we are going to find out when customer like to order master, morning, afternoon, evening or other times. We will solve this query with two solutions. First is unpivoted and the second is pivoted. So the bottom output, as you see, is one is unpivoted version output and the second is a pivoted version output. Both tells the same story, but one is rows, the other is columns. We only need orders table for this query, so let's understand it. From this table, we will only use created at timestamp. It tells when the order was placed. So what we will do in this query, we will classify each order into a period like morning, afternoon, evening or other based on its hours. Then count how many orders fall into each period. After that, we will add a total row or column to show the overall count. And finally, we will show two formats. One is unpivoted, it will show each period as its own row, and the second is pivoted, and this pivoted version show each period as its own column. So let's start writing the query. First, we will start with the select statement. Now for order period, we will use a case statement to check the hour of created date and assign a label. From 5 to 10 we will say morning, from 12 to 15 we will use afternoon, and from 17 to 19 we will use evening, else would be others. Here we will say case when extract hours from created at timestamp is between 5 and 10 then morning. Why we will use extract function? Because it's a date column, so we have to extract hours from this date column using extract function. And the created at timestamp is in a text form, right? So you have to typecast it to timestamp using these double colons. And now we will say between, if it's between 5 and 10, then we will create a morning row. Now in double quotes we will write morning. This will create morning row. Now for afternoon we will copy the same logic, just we will change the hours from between 12 and 15, then it would be afternoon. 12 if it's between 12 and 15. Now evening, here we will write afternoon. Now for evening we will do the same, just we will change the hours between 17 and 19, then evening. Finally in the else condition we will say other. This will create a other row and end as a order period. This column would be order period, right? All the rows of case statement will come into this column. Well, the second column would be order count. We'll count all orders in each label group. Here we will write count star. In place of star we can also use order ID, but it won't be counted if there is a null in order ID column from order column. And now we will group it by order period, because if you are using count or any other aggregate function, you have to use group by clause. Let's run the query to see what it returns. Okay, now the output shows order period column and order count, and in order period there is one row that we need, which is total. So for that we cannot use total, and in order to achieve that we will write another query and then combine it with this query using union all. And here we will add another row total to the order period column. So we will start with select statement, and in double quotes we will write the row name, which is total, right? And you have to give the same name as in the previous query to this column, which is order period. If you don't do that, you would encounter an error. So as order period, and the other column is order count, so count star as order count. You have to use the same quantity of column in the previous query and the same names from orders. So let's run the query to see the output. Now the output shows now the full rows, and finally we will give it a order where morning come first, then afternoon, then evening. But we cannot use order period column So we have to repeat all these two queries into a subquery, and we will say select order period and order count from these two queries, and in from clause we will wrap these two queries, right? Well, now from and it and in these brackets we will wrap these two queries. These are now a subquery. We will give a name to this subquery as a combined result, and now from this combined result we can use order period to order the output. Now for that and finally order by order period. Now first we will say morning, right, because we want morning first, and we will use if order period equal to morning, and now we will use descending order to force the order, right. This will force the order and it will show morning first, and we will do the same for the rest of all, for afternoon and for evening. The descending order will force to show the morning first, then afternoon, then evening, then others. And lastly, we would say order period should be equal to total in descending. Let's run the query. Now the output is now in the same order as we ordered, morning first, then afternoon, evening, and other, and then total. This was the unpivoted version, and now it's completed. So now let's focus on a pivot version. And in this pivot version we will create columns from the rows, like from morning, afternoon, evening, others, and total. The second solution will contain an unpivoted version of this query. Also, you will learn how to create unpivots from pivots in SQL. I will paste the whole solution of the pivoted version here, and we will understand it step by step. So this is the solution. Let's first run it to see the output, then we will understand it. As you can see, it shows all the rows like morning, afternoon, evening, others, and totals as columns. First, let's select all the select statement part and press tab buttons to give it a better structure for a better understanding. Also, let's select this count function part and press tab to give it a better structure. Now it's the time to understand the query. First, we have to understand that we used a count function for each column, and this is one of the best practices to create columns from rows, right. So in that count functions we use case statements, right, but in the previous query we use only case statements to create rows, but here we will create columns using count function. You can also use other functions based on the use case. So for morning and for the first column we use the same logic, just we wrap it up in a count function, and we count only those orders whose hours is between 5 and 10. This case when return 1 for matching rows, null otherwise, and null won't be counted, only 1 will be counted. We repeat the same process for afternoon and evening, just we change the hours. For others, as you see, there is 3 conditions, and this condition tells that if the time is not between all of these, like not between 5 and 10, 12 and 15, and 17 and 19, then it will be counted as others. And finally, for total, we count all orders simply by counting their extracted hour. Every row has a value, so this gives the total from orders table. I hope you understood everything clearly. Let's run the query again. And this pivoted version return every row from the previous query as a column. Thanks for watching. If you have not subscribed the channel, please subscribe it and click the like button. See you in the next video. Hey everyone, welcome back to Data Sync. So in this part of our coffee shop case study, we are going to identify the top 5 best selling items and calculate their total revenue contribution to the business. The below is the output of this query. This is what we'll get after running our query. A ranked list of 5 items showing how many items were sold and how much revenue each item generated. For this query, we are using menu items and orders table. So let's understand the menu items table. So from this table, we will use item name, ID and its price for this query. And now the orders table. From this table, we will use item ID and quantity purchased. We will join orders table with the menu items so we can match item names with their prices. So let's start writing the query. We will begin with select statement and select item name from menu items and item ID from orders table, because we want to display the item name and ID. Now item ID from orders table. Orders data. This is the item ID, right? Item ID. So now quantity sold. For that we will use sum function to sum a total quantity from orders table. This will give us the total number of times each item was sold. So sum order dot quantity, and we will name it as quantity sold, as you can see in the below output. And now the revenue contribution. For that we will use quantity from orders table and item price from menu items table. And again we will use the sum function, right? So sum order dot quantity multiply by menu items dot item price, and this will give us a revenue contribution of each product, and we will name it as a revenue contribution. Let's drop this revenue contribution to the second line and press tab for better structure. From a menu items table. From a menu items and alias MI. This is a short name, right? We use it when joining multiple tables. And now we'll join menu items with orders table based on the common column item ID, so that we can access item ID and quantity from orders table. So join orders alias O on menu items that item ID should be equal to orders dot item ID. O is an alias, and you can think of a short name when we join tables, we use it. And now we will group the data by item name and ID, so we can aggregate the values correctly. 1 2 is shortened for grouping by first and second columns, or you can also use these menu items at item name and orders at item ID. Also remember, if you are using aggregate function in your query, you have to use group by clause. Okay, now we will sort the result by quantity sold. So the highest item would show first in descending order, so the highest quantity sold will show first. And now we'll limit the result by 5, because we only want the top 5 best selling items. So limit 5. So now let's run the query to see the output. Now as you can see, the output shows item name, its ID, its quantity sold and revenue contribution by each product. We sort the result in ascending order by quantity sold. So and now you can see the output shows the highest quantity sold product first. Now in the output, the table was ordered based on revenue contribution in descending order, and we ordered it by quantity sold. So I believe that quantity sold is the best option here, right? Because we are writing the query for the top 5 best selling products, not best revenue products, right? So if you want the same output, then order it by revenue contribution in descending order. Now the output is ordered in descending order by revenue contribution, and it matches the below output I provided earlier at the start of the video. Thanks for watching. If you have not subscribed the channel, please subscribe it and press the like button. See you in the next video. So in this SQL coffee shop case study, we are now working on pricing and product demand analysis. We are going to identify the least selling items in our menu and recommend whether each one should be removed or discounted or kept. This type of analysis is crucial for inventory optimization and pricing strategy in real world businesses. This is the final output of this query. It shows the name, ID, quantity sold, contribution, and a smart status recommendation like remove, discount, or keep. Also, a reason column that explains why we are suggesting that status. This result will help business managers take data-driven decisions on which product to promote, adjust, or retire. We will use two main tables for this query. One is menu item. This table contains item names, categories, and prices, and we'll be using only these columns. Okay, now orders table. This table logs how many times each item was ordered, when, and by whom. We'll be using only quantity and item ID from this table. We'll copy the previous query for the first four columns, which is item name, ID, quantity sold, and revenue contribution. To this query, we'll use a case statement to add two extra columns. One for action recommendation like removal, discount, keep, and the other for reasoning like low sales, high sales. Finally, sort the data by quantity and revenue to see lowest performance first. Okay, so now only we need to add two columns, right? One is status recommendation and the other is reason. Let's run this query to see what it returns. This query returns all the first four columns, right? Now we have to add the other two columns using case statement. Before we write those two columns, let me quickly explain the conditions we'll be using to evaluate each product. I'm using a custom logic based on quantity sold and revenue contribution to decide whether a product should be removed, discounted, or kept. These rules are not fixed, they are tailored to fix this specific case study. In real world scenarios, businesses can adjust these thresholds based on their own goals, market trends, or product strategies. So let's start adding both columns, status recommendation and reason. So first we will say case sum of quantity. If sum of quantity is less than 5, then remove, because there will be very low sales. Also, the second condition, when some quantity is less than equal to 10 and some order dot quantity and menu item dot item price, this would be revenue contribution, right? Is greater than 40, then discount, because this would be high prices items. You can adjust the condition based on your own business goals. Then discount. Now the third condition would be if when some quantity between 10 and 15, then discount, because this would be medium sales between 10 and 15. Also, the last condition would be when sum of quantity is greater than 15, then keep. Why? Because this would be high sales. Keep. Finally, end as the column name status recommendation. Let's run the query to see the column is added or not. So there is error. Let's remove the comma and run again, and you can see the column is edited and it assigns a status recommendation to each row based on the conditions. Now the next column is reason. This will provide the reason behind the recommendation, like if it's a high priced item with low sales or just overall very low sales. We'll copy paste the same logic from status recommendation and just change the recommendation with reason. Okay, so copy the status recommendation and paste it here and just change removal to very low sales. And for the second condition, if quantity is less than equal to 10 and revenue is greater than 40, then it's high prices items. So we should label it high price items. Now the third condition, if the quantity is between 10 and 15, then it's medium sales. The reason would be medium sales. And lastly, if the quantity is greater than 15, then it's high sales. And change the name to reason. Now the query has been completed. Let's run it to see the output. Now remove the comma and run again. The output shows the exact output I have shown you earlier at the start of the query. So the status recommendation and reason have been added successfully and applied to each row. And finally the last step left to order it based on quantity sold and revenue contribution in ascending order. So the lowest quantity sold and revenue contribution rows will appear first. Let's run again to see the output. Now this version shows lowest quantity and revenue contribution rows first. Thanks for watching. See you in the next video. So in our coffee shop case study series, we are working on pricing and product demand analysis, and the query is saying identify best items so far and recommend focus areas for marketing campaigns. So here is what we want to see in the final output. Item name and item category. So we know both product we are talking about and what category it belongs to. Also total quantity sold, the total number of units sold, and marketing recommendation are smart recommendations based on how well each product is selling. Before writing the query, let's understand both tables we are going to use in this query. Now the first table is menu items. From this table we will use item name and category, and item ID will be used to join both tables. Now orders table. From this table we will use quantity and item ID. We will join these two tables using the item ID to combine product details with sales data. So let's start writing the query. First let's look at the output. So we have to select item name and category from menu items. Item name and category. So mi is the short name of menu items. Also you can call it alias. So item name and category from menu items. Now quantity sold, total quantity sold. For that we will sum quantity from orders table. So sum orders data quantity. This will give us total quantity sold when we group it by item name and item category. So we'll name it as a total quantity sold as mentioned in the output. Now marketing recommendations. For that we will use a case statement, and we will set the condition that the case when order.quantity, which is total quantity sold, is greater than equal to 30, then it's a top seller product, and we will suggest strong marketing focus. Right? So case when sum of order.quantity is greater than equal to 30, then recommend top seller and focus marketing. These conditions are customs, right? You can set it based on your business goals or rules. So in the first condition, if the product sold over 30 or equal to 30, then it's a top seller, right? Now the second condition, for that we will say if when the sum of quantity is between 20 and 29, then moderate seller, right? And some marketing, we will recommend moderate seller, some marketing between 20 and 29, then we will recommend moderate seller and some marketing. Now else condition will contain only those product whose quantity sold is less than 20, and here we will recommend low seller, little or no marketing, and lastly end of case statement, and we will name this column as marketing recommendation. Well, now we'll select it from menu items table, and alias mi short name. And now we'll join it with orders table based on the common column item id to bring together product names, categories, and quantities. So both have this same column. We will join it. Now we will group it by menu item name and item category, so that the calculation are done per product. Also, if you are using aggregate function, you have to use group by clause. Well, the query is completed. Let's run it to see what it returns. Now the output is same as we have seen earlier for this query, right? Just we have to, if you see, we have to sort it to show the best selling item first. So for that we will use order by total quantity in descending order. This will order the results from highest selling to lowest selling products. Let's run the query again to see the output. Now the output matches the same output as we have seen in the CSV file, and it shows the top seller product first, then moderator, then low seller. Now let's give it a structure for better readability. As a case statement comes under select statement, and the when statement comes under case statement. So press tab and it will give it a better structure. Thanks for watching. Don't forget to subscribe the channel and hit the like button. See you in the next video. Hey everyone, this is the 16th query of your coffee shop SQL case study. It says list all ingredients that are running low in inventory, quantity less than 5. This is the condition. So let's understand the output of the query first. The output will look like this: ingredient name, ID, weight, measurement, and total quantity based on the condition. Before starting the query, if you have not subscribed the channel, please subscribe it and hit the like button. Let's understand the tables we are gonna use for this query. First is ingredients. This table contains information about ingredients. We will use ingredient info from this table. The next one is inventory table. It tracks how many units of each ingredient are in stock. From this table we will use the quantity to track how many units we have, and we will link both tables using ingredient ID. We will group the data so we can sum up quantities for each ingredient. Additionally, we will use CTE to create a temporary table that holds the ingredient details along with their total quantity. We'll filter the results to only show ingredients with less than 5 units left. Finally, we'll sort the result so the lowest stock appears first. So let's start writing the query. We will first select ingredient ID from ingredient table and we will donate ingredient table as ing. So ing dot ingredient ID. Now ingredient name, it's the name of ingredient. Ing is the short form of ingredient. Now ingredient weight, ingredient measurement, the output. Now we'll call it as measurement. Finally, if an ingredient has multiple entries in the inventory, we will sum them up to get the total stock. Right? For that, we will use sum function. So sum of now we need quantity, and we'll get that quantity from inventory table. This is the quantity for each ingredient. We'll donate inventory table as in. So inventory dot quantity. Finally, we'll name it as a quantity left. So here we will write from ingredients table and then we will join it with inventory using ingredient ID from ingredients alias ing. That's a short name. Now we will join ingredients with inventory so we can combine ingredients detail with their stock level. Now for joining we'll use the common column in both tables which is ingredient ID. The join condition makes sure we match the right ingredient with its inventory data. Now we will group by ingredient details so the sum function works correctly and gives total quantity for each ingredient. We'll group it by all the details, right? Except the quantity left. So we'll group it by all columns except quantity left because here we used aggregate function. Let's run this code to see the output. In the output you see ingredient ID in its name, weight, measurement and quantity left. Now we have to apply a condition so we can only get ingredients with fewer than 5 units left. For that we will wrap this code in a CTE. CTE is a temporary table and then we will select all details from it and apply condition. So we'll start with the and we'll name it ingredient, it's a quantity, and as this is the syntax you have to use with clause and as the temporary table is now created. Let's select all details from it and apply the condition. So select all from ingredients quantity. For condition we will use where clause, where now quantity left, that's the quantity of products that are left in the inventory, and we will apply the condition that if the quantity is less than 5 then retrieve the product names and its detail. The query is almost completed, but the structure is a bit messy and hard to digest. So we will select the inner part of CTE and press tab to give it a better structure. Let's run the whole query to see the output. Now you can see it returns ingredient ID, its name, weights, measurement, and finally quantity left. The output is the same As mentioned in the CSV file, we just need to give it an ascending order. So the list stock appears first. We will order it by quantity left. So the ingredient with the list stock appear first in ascending order. Let's run the whole query and see the output. Now here in the output, it matches the exact as I shown you in the CSV file. The query is finally completed. Please subscribe the channel and hit the like button. See you in the next video. Hey everyone, welcome back to the testing. So today we are working on a very interesting SQL problem. That's the 17th query of our coffee shop case study, and it's saying identify the number of shifts a staff member has worked since the beginning of the year. The below will be the output of the query. First we will show staff ID and its total shift worked. We are gonna use rota table for this query. We will use staff ID, shift ID and date columns from this table for our query. Before we start writing the query, please make sure to subscribe the channel and hit the like button. It's a small click for you, but it means a lot to us. I will explain everything as we write the query, so please listen carefully. So first we will select staff ID and date on which they worked. Now what we are going to do is to use a row number window function to give each shift a unique sequential number starting from 1 for each staff member. So first we will write a row number function and then over clause. In over clause we will write a partition by staff ID. This ensures that each row number adds up by each time when staff ID comes in staff ID column. And now we'll order it by order data to ensure shift ranks chronologically for each staff member, and we'll finally name it as a row number. We are selecting all this info from rota table, so here we'll write from rota table, from rota. Now we want those shifts that were recorded since the beginning of the year. For this we will use where clause and we will say that extract those shifts that were recorded since the first day of the current year. So where date is greater than equal to the first day of the current year, which is 2024 0101. So this will ensure to extract only those shifts that were recorded since the beginning of the year. After running this part of the query, we get staff ID, the date they worked on, and the row number for each shift of each staff member. Now we will use this data as a temporary table for our query. We will wrap up this code in a CTE. CTE is a temporary table, right? And we'll name it as order shifts. Now from this CTE we will select a staff ID and its maximum row number. The maximum row number will be their total shifts, right? Because every row number will sum up when a new shift comes up for each employee. The syntax of a CTE is first you have to use with clause, then name, then s keyword, and wrap the code in two braces. Now we'll select those staff IDs and their maximum row number. Maximum row number will be their total shift worked, right? So let's select the records from the CTE. First we'll select staff ID and then we'll use max function. This will select maximum row for each staff member and it will be total shift worked. So max and we'll pass row number inside max. So this will select the total shift worked. We will give a name as total shift worked as mentioned below in the output. Now from order shifts, so because we are selecting it from a temporary table, we will group it by staff ID, so we will only get the results for each staff member. Also, if you are using aggregate function, you have to use group by clause. Finally, we will order it by total shift worked in ascending order. So we will get the result in ascending order. Let's run the query to validate the output. Now you can see it shows each staff ID and each total shift worked as mentioned in the query output. Now we will also work on the second solution of this query. It's very simple. You have to change some parts of the below code. Right. Now instead of max, we will use count function. Let's look at the rotor table. Here for each staff member, we will use a count function to count shifts, right? And instead of shift ID, we will use star inside count function. Star ensures we count even null shifts for each customer. In from clause, we will use rota instead of order shifts. Everything else will be same. So let's run the query, and the output shows the exact as the previous query and the output I have shown you earlier. Please subscribe the channel. See you in the next video. Alright guys, in this video we are gonna figure out which menu items are frequently ordered together. Not just pairs of items but also chains of 3. So basically if someone ordered coffee and muffin or coffee muffin and sandwich, we want to capture that as a chain and count how many times it happens. Now we cannot just jump straight into 3 item chains. We first need to build our query for 2 item chains and then extend it to 3. Let's go step by step. Before, if you haven't subscribed the channel, please subscribe it. It's a small click for you, but that means a lot to us. So before starting the query, let's first understand the output. The first column we will retrieve is item chains. In this column, we will retrieve products with its chains. If one order contains many product, we will chain it together. The second column is frequency means how many times these chains were ordered by customers, right? The third is chain length. The chain length means how many product included in the chain, either 3 or 2. Now we understood the output. Let's understand the tables we are gonna use for this query. The first is orders table. It contains order ID, date column, and item ID, quantity, customer name, in or out, but we are going to use order ID and item ID from this table. The second table is menu items. This contains the names of the items, so we will join it with orders table using item ID and then retrieve item name. First, we will work on 2 item chains because in one order maybe 2 items were ordered by customers. For 2 item chains, we are gonna use one other copy of orders table. So let's start writing the query. First, we will start with select statement, and then if you see, for each order there will be 2 product order. For example, for order 6, item 1 and 16 were orders. So from the first copy of orders table, we will select one item, and for the second we will select second item. So let's write it. So first we will use order ID, then we will change it to item name. So order 1 data item ID. If you see in the output, there is an arrow between products or items. So for that we will use concatenation operator in Postgres SQL, and now an arrow in double quotes. if you see in the output there is an arrow, right? So for that we'll use an arrow and again double quotes. This is called concatenation. When you want to join two columns or rows into one, then use it. Also you can use the concat function for that. Now from the second order copy we will write order 2 dot item id. This will create a chain for item 1 and 2 and we'll call it as item chain. Now for frequency we are gonna use a count star function to count how many times these items were ordered in other orders by customers. So count star and we'll call it as frequency. We can also use item chain in the count star function, but star avoids missing values, so that's why it's the best choice. Now chain length. So in the output you see 3 and 2 chain lengths is because we will union the 2 chain length query with the 3 chain length query. So we will write it as 2. There is 2 chances, so we will write is 2 as chain length. Now we will select all these from the first copy of orders table and we will call it as order 1. Now we'll join it with the second version of orders table using the same orders id, because there will be 2 items for one order. So let's write it. We'll write join orders order 2 on order 1 dot order id should be equal to order 2 dot order id. This condition makes sure both items belong to the same order. Let's add another condition because if I don't add another condition, I will get duplicates like coffee muffin and muffin coffee. So I write order 1.id should be less than order 2.item id. This will force a strict order. Only keep the pair where the first item's id is smaller. The way each unique combination only appear once. Why I used and instead of or? Because I want both conditions to be satisfied, not just one. Now we will use group by item chain because we want frequency to be counted for each item chain. Also remember, if you are using aggregate function in your query, you have to use a group by clause. So let's write a group by item chain. Let's run this part of the query to see the output. Now you can see it returns item IDs, its frequency and chain length. Now we will replace item IDs with item names by joining order table versions with menu items versions. If you see in the menu items table, there is item name. So we will retrieve this name using item ID. So let's join orders tables with the menu items. First we are gonna write join menu items and we'll call this as mi1. This is the first version on order 1 dot order id item id equal to mi1 dot item id. This will retrieve item name for order 1 item id. Now for order 2 we'll do the same. If you see in the orders table, for each order there is 2 items. So for that order we'll retrieve the second item id name. For that we will use the same join, just we will change the versions. So we will copy paste the same join, just change the versions like replace mi1 with mi2 and order 1 with order 2. Finally we will change the item IDs with item names, also order 1 with mi1, and for the second we will do the same. This will retrieve item names instead of IDs. Let's run this part to see the output. Now I think there is a mistake because it's showing same items in the items chain. Let's look at our code to see where did I made a mistake. So if you see I used mi1 instead of mi2, so let's change it and again run the code. Now you can see the item names are retrieved with frequency and its chain length. Now we have two item chains. It's actually pretty easy to exchange the logic for three. Now we'll join both queries using union all. The second query will be for three item chains. We'll copy paste the same code. Here the first thing we'll do is to add another item by concatenating with the two item chains. So this will create a three item chains. Let's copy this part and paste it there. This will create three item chains, right? The second thing we will do is to bring the third row or order 3. It will represent item 3 in the orders table. So for that we will copy paste the same joiner, just we will change order 2 with order 3. So let's copy this joiner and paste it here and change the orders 2 with orders 3. Now for the third item name we have to add another version of menu items and we'll change just 2 with 3. So let's run the whole query and see what it returns. So I made a mistake here, let me see it. So I forgot the two concatenation operator here. Let's run the query again. So this is the result. Before evaluating it, let's first give it a better order. In the first order, we should show the three item chains first, and in the second order, we should show the maximum frequency items first. Now for that, first we will order it by item chain in descending order to show maximum item chain rows first. Descending. And in the second order we will use frequency, but in descending order. Frequency in descending order will ensure that after chain length show the highest frequency rows first. So frequency in descending order. Let's run the whole query. So in the output I think there is something wrong. So we'll look at our code and see what I did wrong. So in the third joiner with menu items 3, I used order 2 dot item id instead of order 3. So let's change it. If you are copy pasting something, you need to be very careful because it's likely that you will make a mistake. So after running the query, I think there is still something off in the output because it doesn't measure the expected output. So let's look at our code. Where did I make a mistake? I think the mistake is in the joins because the output is not matching the actual output. So the error is in the second condition when we are joining order 3 with order 1. So here we ensures that the order is consistent, meaning it doesn't repeat itself in reverse order. But below here we used order 1 instead of order 2. Now the second condition, this ensures that the second item should not repeat itself with the third item and ensures consistency. Let's run the whole query again. Now if you see at the output, it matches the exact output as I shown you earlier at the start of the video. Also we first ordered it by item chain in descending order, and then with frequency, and it shows the exact order. So the first three rows is from the second part of the query. It shows three item chains. If we run the second part, it will only retrieve three rows because there was only three times when customer ordered three items together. So this is the output of the query. If you have any question, you can ask me in the comment section. Also, if you haven't subscribed the channel, please subscribe it, like the video, and share it with your colleagues or classmates. See you in the next video. For now, take care. Hey everyone, so in this video we will find out customers with 10 plus orders spread over 5 or more days for loyalty rewards. That's the 19th query of our coffee shop case study. So first let's understand the output of the query. So we will extract customer name, their total orders, and distinct order days. Distinct means they must be unique. We will extract it step by step. First, let's understand the tables we are going to use. The first is orders table. From this table, we will use order ID or count of order ID, and created a date column. Also, customer name to identify which customer have 10 plus orders spread over 5 or more days. So first we will start with select statement to select the columns. So select and first customer name, we'll select customer name, and now we have to find total orders. For that we'll use a count star. We can also use a count order ID, but count star will also include the missing values from the order ID column. So the count star will give us total orders for that customer. We'll name it as total orders. Now in the output, now we have to find distinct order days. For that we will use count function again, and inside count function we will count days. For that we'll use a created date column, and inside count function we'll also use a distinct keyword. Distinct keyword will ensure that we only select unique days. So we'll write count, and inside count function we will use distinct keyword. This will ensure that we only select unique days. So this date column also have time alongside data. This causes to show each row as unique, but we want days. So for that we will convert it to data instead of timestamp. It's now timestamp, right? The type of this column is text, so we have to typecast it to date column by using two colons. The two colons ensure typecasting, and we'll name it as distinct order days. This will extract distinct order days for that customer. We are selecting this from orders table, so here we'll write from orders. We want all the aggregation for customer, right? So we have to group it by customer name. Also, if you are using aggregate functions, you have to use a group by clause. So group by customer name. Now it's condition time to apply conditions on that query. For that we will use a heavy clause instead of where, because we cannot use aggregate functions in where clause. It will cause an error. So we will write as having, and in the first condition we will say that the orders or total orders should be greater than equal to 10, as mentioned above in the question. Also we will use AND operator to ensure that both conditions must satisfy before retrieving the data. And for distinct order days we'll copy paste the same count function, and here we will write as greater than equal to 5, means a distinct order that should be greater than equal to 5. For typecasting to that type, you can also use a cast function instead of two colons. So first you need to write a cast to tell SQL that it's a cast function, and create that column inside cast function and write as data. This will typecast it to that type. So it's on you, either use two colons or cast function for typecasting. Let's run the query to see the output. Now we have made a mistake. So instead of creating data, we wrote create. So created data and also below created data. Let's run again. Now you can see in the output it matches the exact output as I shown you earlier at the start of the query. So to validate the output, we need to comment down the condition part. We have to order it by distinct order as in descending order to see which customer have distinct orders that's greater than 5 or equal to 5. Let's run the bot. You can see Queen and Sam have 10 plus orders and 5 and greater than 5 distinct days. The rest of have total orders greater than 5, but they don't have distinct order days equal to greater than 5. Finally, the query is completed. Please subscribe the channel and hit the like button. See you in the next video. In this video, we will write one query that picks the top selling item for every time window, like morning, afternoon or evening. We will break a single SQL query into simple steps. First, we need to understand what the output looks like. So in the first column, we will retrieve time of day. In the second, item ID. In the third, its name. And in fourth, total order count for that item ID or item name. Now let's understand the tables we are going to use for this query. First is orders table. So from this table we'll use order ID to count total orders created. That's a timestamp column. So we will use that column to retrieve time of day like morning, evening and so on. Additionally, we'll use item ID to retrieve which item is the most popular by time of day. Next table is menu items. It has all menu items info. From this table we'll use item name and we'll connect both tables using item ID. Then we'll be able to get the item name. I will explain every step clearly, so watch till the end. The query is very complex. First we'll retrieve necessary information from orders table. We will start with select statement and first we'll pick item ID from orders table. We'll use O as short name for orders table and we'll select as O dot item ID. Now we'll retrieve time of day like morning, afternoon or evening. For that we'll use created data column. There's a timestamp column, so we need to retrieve hours from it. Then we'll be able to extract time of day. Right. For that we'll use case statement in SQL. So we'll write as case and then when. For extracting hour from created a timestamp, we'll use extract function in Postgres SQL. So we'll write extract hour from orders data created date column. Created data. That's a text. Its data type is text, so we need to typecast it to timestamp. then we'll be able to extract hours from it. Otherwise, the extract function won't work on it. For that, we'll use two columns to typecast its data type from text to timestamp. Now the condition is case when hour is between, we'll say if it's between 5 and 11, between 5 and 11, then it's morning. So between 5 and 11, then morning. This will help us to count orders for each item ID in the morning. So this condition says that if the time or the hour is between 5 and 11, then label it as the orders happen in morning. We will copy paste same conditions in that case statement, just we will change the hours. So if it's between 12 and 16, then we will label it as afternoon. So this will count all orders for afternoon for each item ID. The same we will do for evening. We'll just change 5 to 17 and 20. If it's between 17 and 20, then evening. This case statement will retrieve one column, right? For a clear structure, select the when statement and press tab 4 times. Because it came under case statement, so we need to show it like that. Finally, we will end this statement using AND keyword, and we'll name it as time of day. This will retrieve a column time of day. Let's look at the output. We successfully retrieved time of day and item ID. Now we'll focus on order count. For order count, we'll use a count method to count all the orders for that item. Inside count function, we can use order ID or star, but star will also count missing values. Lastly, we'll name this as order count. Now we need top items in each time of day based on its order count. For that, we'll rank it and pick the first one. For ranking, we will use a row number. This will give rank to each item ID based on its order frequency within a time of day. So let's write it row number. In our class, we'll write a partition by time of day. This will divide ranking in each time bucket, like in morning, afternoon, or evening. We'll copy paste time of day code into the partition by clause. We cannot use time of day directly. Well, we want to rank item IDs in those time buckets by its order frequency. For that, we will use order by count star. Count star is the order count in descending order. Descending will ensure that item ID should rank based on order count from highest to lowest. So the order by clause will looks like order by count star in descending order. We'll call this row number function as a rank. This will retrieve a column of rank. We have to use O dot before created it because we are selecting it from orders table, and O is the short name or alias of orders. So O dot created it. We'll select all these from orders, and its short name will be O. Now we have to use group by clause. We'll group it by item ID and time of day. So order dot item ID and time of day. This will ensure that we get total order count for each item ID within each time of day. Let's run this part of the query. Okay, we got an error. We have to use comma after each column. Now in the output, you see it retrieved item name, its time of day, its order count, and the rank. You can see it shows a rank in each time of day, like in evening, morning, or afternoon, and it ranked items based on orders count. Now we have to do two things. First, to select those items whose rank is 1, and second, we need to add item name to match the output. Now what we'll do is to wrap this code in a subquery, or you can say it will act as a table. We need to use two braces, first at the start and second at the end, and we'll name this as T. You can give your name based on your choice. Now we'll select data from the subquery or T table. So first we will start with select statement, and we'll select T dot time of day. First time of day. Now we have to select its item ID, T dot item ID. It's now from menu items we will select item name. So mi dot item name. Mi is the short name of menu item. Now the last column will be order count from T table or from subquery, right? So T dot order count. We are selecting it from T table, so we will write from and this T table. This is also a subquery, but you have to name it if you want to use it as table. Now the subquery come under from statement, so select all of it and click tab button to give it a better structure. To get item name for each item ID, we need to join both tables using item ID. This join will ensure that we get the right item name for the matched item ID between both tables. So join menu items mi on T dot item ID should be equal to menu item dot item ID. Now finally we will select those items whose rank is 1. So in where clause we'll write where T dot rank equal to 1. Now we will get rank 1 item for each time of day. The query is finally completed, so let's run the code to see its output. Select all, run it. Okay, we have to use mi after menu items. Now after running the query, you are only seeing morning and afternoon. The evening is missing, so let's run the subquery to see the top item for the evening. Let's scroll down to the evening part. Now you can see item 26 is the first rank item for the evening. So let's look this ID in the menu items and its name. So there is no item 26 in this table, and that is the cause of not showing evening in the output, because there is a null in the item menu items table. When we are connecting both tables, we are using inner joiner. We have to use left joiner to ensure we select all rows from T table and matching rows from the menu items. Let's run the code again. Now you can see there is a null in the evening because in item name there is no item 26 in its name, so it's showing it as null. So if we have to use a placeholder for null, we will use quels function in SQL. So for menu item column, we'll use calls method to show a placeholder like no item instead of null in the output. So coils in the first parameter you have to pass the column, and in the second if there is a null we will show this. Here we'll write no data instead of null. So when we run the query we will see no data instead of null. So no data, we'll use the same calls method for item id, because if there is any missing item id, this will show item id as no data or no item. If the query is completed right now, but for safety purposes you can use calls method to ignore nulls in your output. So you can write it no item in the second parameter. Well, now I think the query is completed. Let's run it to see the final output. Well, you can see the output. It shows time of day, their item IDs, their item names, and its order count. If you look at the output that I shown you earlier at the start of the query, it matches the same output that we retrieved with our query. The query is completed, but what I want you to do is to change the column names from coils to item ID and from coils to item name in the output, as you can see. I hope you can do it. If you haven't subscribed the channel, please subscribe it and hit the like button. See you in the next video. Which shift made the most money and who was on duty? In this video, we'll find out in 3 simple steps. Then list the employees who worked that shift. Let's look at the final output of this query. Our final output will have shift ID, the shift code, staff ID, each staff member assigned to that shift, and shift date, the date of the shift, and total shift revenue, money made during that shift. Before writing the query, let's first understand the tables we are going to use for this query. So the first table is a rota table. This table contains date, shift ID, and staff ID. We'll need those 3 columns from that table. Let's look at the second table, orders. We'll use this orders table to calculate revenue by joining it with menu items. Also, we'll use the created column and quantity from this table. Menu items. We will calculate total revenue. To do that, we will use the item price from this table. Now shift table. This table contains information about shifts. So we will use start time and end time from this table. We'll join this table with other tables using shift ID. So let's start writing the query. Before, if you haven't subscribed the channel, please subscribe it. So first what we will do is to select shift ID and its state from rota table. We'll start with select statement to select, and from rota table we'll select shift ID to identify each shift by its code, also its data. So we will represent rota table with R. So r.shift ID and r.shift data. So in output each shift data, so we will name it as shift data, r data data as shift data. For revenue, we will multiply quantity with its item price by joining orders table with menu items table. So in orders table we have quantity column, right? And we will join it with menu items by item ID, and we'll calculate total revenue by multiplying item price with quantity. We will take sum of it. This will ensure that we sum all lines in that shift. So sum orders dot quantity multiply by multiply sign menu items dot item price. This will give us total revenue for each particular shift. Let's name it total shift revenue as mentioned in the output as total shift revenue. Well, in from clause we will write from orders alias O. We can also use another table here in place of orders, but I believe orders is great choice. So from orders O, now in orders we have item ID. So we will join these orders with menu items using that item ID. So join menu items alias mi on o dot order id item id should be equal to menu items at item id. This will ensure we get item price for the matching item id. If you look at the rotor table, we only have date column to join orders table using that date column. So from orders table we will use a created date timestamp column and we will extract date from it. This will ensure that we match each order to the calendar date of the rota. So we will write it as join rota r on orders dot created data. Now created date is a timestamp column, so we need date only. For that we will use two columns and then date keyword to extract date from it equal to rota dot date column. So we need total shift revenue for each shift id. For that we need to group it by shift id and data. So group by shift id rota dot shift id and or dot data. Also if you are using aggregate function you have to use group by clause. Let's run this part. Now you can see three columns shift id, shift data and its total revenue. Now we need to ensure that the revenue should be calculated between start time and end time of each shift. For that we'll use a shift table. This table has start time and end time. So in where clause we will mention it. First we need to join shift table with rota table using shift id. So join shift alias s on rota dot shift id should be equal to shift dot shift id. Finally we need to write a condition in where clause and you know where clause comes after joins. So in where clause we will say orders dot created date and we'll extract time from created date, not data this time. So if you look at the orders table we have created a column. We will extract time from it. For that we'll use two columns and time keyword. So we will write as order data created data two columns for typecasting time between shift dot start time and end time. Now this condition will ensure that we calculate total revenue or total shift revenue between start time and end time, not beyond or before it. Shift dot end time. In this where clause start time and end times are shift times. So let's run this part of the query to see what it returns. You can see it returns the same three columns, but right now the condition is applied and shift 1 has the highest revenue 582. Now we have to find a staff for this shift, then our query will be completed. Now first we will convert this output into a table. For that we will use the CTE common table expression. We'll start with case and shift revenue, that's a CTE name, or you can say a temporary table name, as and into braces we'll put this code. So the code comes under the CTE. We'll select the whole code and press tab to give it a better structure. We need employees for the highest revenue shift. So here now we will assign staff IDs to those shifts. And finally we will select the top revenue shift and its employees. Now the shift revenue city will now act as temporary table for us. Well, so now let's start writing the code. If you look at the row table, it has a staff ID and shift ID. Also the city we have a shift ID. We will join both the shift revenue city and rota table using shift ID. So shift revenue, that's a short name SR of shift revenue dot shift ID, and from rota table we will select staff ID. So this is staff ID in rota table or dot staff ID. Now we will select its shift data from shift revenue. So shift revenue dot shift data, and finally we will select its total shift revenue. In from clause we will write from shift revenue alias SR. SR is the short name, right? So from shift revenue, then we will join a rota table on shift ID, because both shift revenue and rota table has shift IDs, so we can join it. Well, so join rota R on shift revenue dot shift ID equal to rota dot shift ID. Both table have also date columns, so we can also mention it in this join as a condition. So this is the date column in rota table, and also we have date column in shift table. For that we will write and shift revenue dot shift date should be equal to rota dot date. This condition will adds up extra layer of authenticity. Now let's run this part of the query to see if the staff ID is assigned or not. So select all and run it. You can see in the output we have successfully assigned staff ID to each shift. Finally, what we will do is to select highest revenue shift and its staff ID. Then our query will be completed. Our goal is to now select the maximum revenue shift, and then we will get staff IDs for it. For that we will use or write another CTE to get maximum shift revenue, and we will write it as max revenue as two braces, and here we will write as select. To select the maximum revenue row, we need to use max function in SQL. This will select the top number of row from total shift revenue. So max total shift revenue, and we'll call it as maximum revenue. from shift revenue. If you are using the second city in your code, you don't need to use with keyword. Now we have maximum revenue. Let's run this part of the code. Okay, you can clearly see that shift id 1 has the highest revenue. So in join we will use a join as condition in the select statement to select only the maximum revenue row, right? So here what we will write is we will join maximum revenue with total shift revenue, right? So join maximum revenue this city alias mr on shift revenue. The total shift revenue should be equal to maximum revenue dot maximum revenue. This will select only one row, the maximum revenue, right? And this join act as a condition. So SR the total shift revenue should be equal to maximum MR dot maximum revenue. Let's run the whole query. You can see shift 1 have the highest revenue, and the stuff that was assigned to it is 1 and 3, and it matches the exact output as I shown you earlier. 582 is the highest revenue for shift 1 and stuff id 1 and 3. The query is finally completed. Please subscribe the channel and hit the like button. See you in the next video. For now, take care.